In this video, I wanted to go over mass percent and how we calculate mass percent when we are trying to determine the mass that's contributed from a particular element to an overall compound's mass. So the formula for mass percent is just N times the atomic mass of an element, okay? Atomic mass of an element divided by the molecular formula or the formula mass of a compound. Molecular. I don't know what's going on with my stylus, but it's all weird today. And then multiplied by 100%. Okay. Now the N here is the number of atoms that is contributing to the overall compound, right? So for instance, in like carbon dioxide, which is an example we'll do in a minute, the carbon dioxide has one carbon, so N would be 1, or 2 oxygens, so N would be 2 for oxygens. It's just the number of atoms. So if we take a non-molecule example for a second, look at this tray of marbles we have right here. So this total tray, this whole apparatus, if you will, adds up to 16 grams total. Now we want to see what the percentage of these yellow marbles are contributing to the overall mass, right? So the way we do that with mass percent is that you have 3 yellow marbles, okay? 3 yellow marbles, each one of them weighing 1 gram, right? And then divide that by the total mass of the marbles, which is 16 grams, okay? And then if you multiply by 100 in order to get to the percentage portion of the equation, right? We end up getting to 19, if you do the math, it's plug it into your calculator, it's 19%. Okay, that means that the yellow marbles contribute 19% of the mass to this whole tray of marbles here. Now let's apply this concept to a chemical compound. So let's figure out what the mass percent of each element in carbon dioxide is. Right, so we have CO2 here. So first we need to determine what the mass of each of the elements is. Okay, so carbon is 12.01 grams per mole, or AMUs. Okay, and oxygen, one oxygen atom is 16.00. For our purposes, that's fine. Grams per mole. Okay. Now, if we wanted to determine what the percent of the percent mass that carbon contributes to the CO2 compound, we simply say that the percent carbon is equal to, since there's only one atom of carbon in the CO2 molecule, our N is 1, right? And we multiply that by 12.01, okay? And then we divide by the total mass of CO2, which is 44.01 grams per mole. I do not know what's going on with my stylus today. Okay, so 44.01 grams per mole. They multiplied by 100%. And then this comes out to 27.29%. 27.29%. Okay, now let's do oxygen. So if we do percent oxygen, that is the amount of mass that oxygen is contributing to the overall CO2 molecule, right? So we have 2 atoms in the CO2 molecule, yeah, 2 atoms of oxygen in the CO2 molecule, Now we take, so that is our N, so we do 2 times 16.00 divided by 44.01 times 100%. And this comes out to 72.7%. Now notice, because there are only 2 elements for CO2, right, only 2 elements, notice that their mass percent compositions do in fact, when you combine them, they add up to 100%. So this confirms that our math is indeed correct. All right, now let's try an example with a little bit more going on. So let's look at what the percent composition by mass, or mass percent, of aspirin is. So aspirin I have over here, over on the right hand side. This is just, so you could use the picture right here to determine what the formula is, the molecular formula is, and then you can use the molecular formula to determine what the total mass of your compound will be. And this one is 180.15 grams per mole, or AMUs, okay? 180.15 grams per mole. So now that we have the total and the molecular formula, we can determine what the percent carbon, the percent hydrogen, and the percent oxygen that each of those elements are contributing to the overall compound. Okay, so let's do percent carbon first. So since there are 9 carbon atoms in the aspirin molecule, our N is going to be 9 times 12.01, which is just the atomic mass of carbon, right, divided by the total, and this is going to be 60%. Once you do all of the math, 60% of aspirin is coming from the carbon atom. Okay, now let's do hydrogen, percent hydrogen. And also keep in mind that hydrogen is significantly smaller than carbon. So even though there are 8 atoms of hydrogen in the aspirin molecule, it is not a very big atom, so it's not going to contribute much. So you have the 8 times 1.00, the atomic mass of hydrogen, divided by 180.15 times 100. Come on, stylus. And that comes out to only 4.48%, right? So it has 8 atoms in the aspirin molecule, but it only contributes less than 5% of the total mass. But this makes sense because hydrogen is such a small atom. All right, now let's go and do the last atom that is in aspirin. Let's see how much oxygen contributes to the whole deal. Now there are only 4 atoms of oxygen in the aspirin molecule. So we take N is our 4, and N is 4, and the atomic mass of oxygen is 16. Divide that by the total, multiplied by 100, and this comes out to 35.53%. Now, just like we saw with the carbon dioxide example, notice that all of the percentages of these 3 atoms, they all add up to 100% total. And this is good because this means that we did all of our math correctly, and each one carbon, hydrogen, and oxygen, each atom is contributing some portion to the overall mass, and it equals 100. And that's how you do mass percent.